Welcome to creating science experiences within the GT classroom. We are excited that you have joined us for this year's GT conference here at Region 10. So today's agenda is kicking off with a quick introduction of who I am. Then we are going to dive into 3 areas in which the science classroom allows for differentiation and meeting the gifted and talented students' needs. These areas are investigable questions, investigations, and discourse. In each of these areas, we will talk about what it looks like and how to use these areas to meet the needs of our gifted and talented students. Finally, we will wrap everything up with some additional resources, some reflections, and some steps that you can take to immediately implement in your classroom. So let's get started. My name is Jennifer Culver, and I am the scientist consultant here at Region 10. Previously, I've been a K-12 grade science coordinator, an instructional coach, and a science teacher teaching gifted and talented students. When I'm not working at the Region Center, I'm either playing with my dogs, gardening, or quilting. But let's get back to the purpose at hand. How can we enrich the lives of our gifted and talented students in our science classroom? One of the areas in which we can differentiate instruction to impact the GT instruction is investigable questions. Historically, in science classes, teachers are given questions for the students to investigate. But what if we allowed students to create their own investigable questions? Some of you may be thinking, oh my goodness, that would cause chaos. But actually, we can do it in a controlled way. In fact, it would give opportunities for students to use their depth and complexity icons of multiple personalities, perspectives, and unanswered questions. Before I dive into that, let's dig a little deeper. What is an investigable question? An investigable question leads to practical investigations. This means that students can collect data, analyze data to identify relationships, and communicate their findings through hands-on experiences. Non-investigable questions are general inquiries in which answers can be found by looking them up on the internet, and all the answers are the exact same. If a student were to ask, how do plants grow? This is a good example of a non-investigable question. The answer can be found by looking at a science textbook, researching online, or even watching a time-lapsed video of a growing plant. Answering the question doesn't involve students using science process skills, such as collecting data, analyzing data, or drawing conclusions. These can summarize the information they find, but it also means that every student has the exact same answer to the exact same question. And an investigable question is in which could be which brand or amount of fertilizer will make plants grow taller. In this investigation, students can identify different brands or amounts and personalize their investigation. This question will require students to collect data, analyze it, and ultimately create conclusions to answer their own investigative question. In this, each student could potentially have different results and conclusions from each other. Another factor in determining if a question is investigable or non-investigable is whether or not the content can be measured. An example of this is the question of whether a fish gets angry if you take away its food. We can take away food from an animal, but can we measure whether a fish has feelings? Actually, at this point in the research, scientists believe that fish do not have feelings because they don't have the neurological development. Fish can't talk. They don't have facial expressions that will give us clues to whether or not they're angry or happy or sad. So this is a non-investigable question. We could change it so that the investigation is investigable and we could collect data. The question could be changed to, Do fish lay fewer eggs when they have less food? We could measure the amount of food and the number of eggs that the fish produces. Let's discuss one more example. In the winter, we talk about how cold it is outside. We might ask the question, what prevents ice from melting? This is a non-investigable question because it's too general and generic, but it is a great starting point. But what if we lead to another investigable question? An example would be, what method would melt the ice on the road the fastest? These are just some examples of investigable and non-investigable questions. But I bet you're asking, well, Jennifer, how does this play into my classroom? So here are some simple and easy steps. First, I would give the students a phenomena to watch. You can select the phenomena that is engaging and on the content selected by the TEK that you're covering in your classroom. Second, I would ask the students to create a T table or a T chart of what they see and what they wonder. It doesn't matter what their wonderings are. We just want them to write down their observations and start writing down questions from those in a process. The third step is to select the specific topic within the content. In this step, the students select the topic of which exactly they are curious about. As a facilitator teacher, we'd ask students to drill down their topic to identify specifically what they want to investigate. The fourth step is where students use syntax stems to turn their topic into an investigable question. As a facilitator, we ask students to identify the variables, making sure that the items that they are picking is measurable. Ensure that it is their specific investigable question is open-ended. Finally, a great practice is getting students to peer edit each other's questions. This allows students to practice giving and receiving feedback. With this step, students need to be taught sentence stems and what to say and what to do with the feedback that is received. As we reflect on this process, it is great for gifted and talented students because it allows them to ask more in-depth, rigorous questions. If we look at the depth and complexity icons, then we can ask GT students to look at the phenomena from different perspectives. We can also increase the academic vocabulary and/or level of questioning at higher levels. Finally, it allows students to ask the questions that they have been burning in the back of their brains. So let's practice these steps for ourselves with a sample phenomena. Before we watch the phenomena, we need to create a T table of what you notice on one side and what you wonder on the other. Feel free to pause this video and start again when your T table has been completed. Here is a local phenomena of some sunflowers growing in the backyard. We're going to watch a time-elapse video of it, and I'm going to hit the play button right now, and I want you to write down what you notice. Interesting, isn't it? Now look at the observation list and make a list of wonderings. For example, I see that the sunflower on the left was tied pretty tight to the black pole. I noticed that this sunflower did not move. I wonder why this sunflower and its leaves did not move while the other sunflower's head and leaves moved right to left and then left to right, depending on the movement of the sun and the moon. Now, it is your turn to pause this video, list out your wonderings on your T-chart. If you need to, you can rewind the video and rewatch the sunflower video clip again. In the classroom, when we are using video viewing phenomena, it is common to watch it over and over again to allow students to make a complete list of their observations and their wonderings. At this point, you should have a list of notice and wonderings. I am sharing my list. Keep in mind that not everybody will have the exact same list. We all have different perspectives, so we will notice and focus on different things. In the classroom, I would be asking students to share their list with each other so they can admire and acquire ideas that they have not previously listed. So feel free to pause the video to give yourself time to craft your question. So here are some investigable questions that I've created based on this video. Is your question similar to the one of mine? The beautiful thing about this process is it allows students to create their own questions. The questions can easily be scaffolded for different levels of cognition, amount of background information acquired by students, and student interest. This empowers students to allow them to have ownership of the learning in that they have some control over selecting their questions. They can use their background information and they can create questions that interest them as well as challenge them to look through things through different perspectives. Now, as we continue from creating investable questions, we need to create the investigation. This will lead us to our third area covering in this presentation: investigating and engineering design processes. This process will allow us to use the depth and complexity icons of rules, details, trends, and patterns. This section is very important for gifted and talented students because it gives them the opportunity to face challenges, think critically, and think creatively as they implement an investigation or an engineering design process. For this section, let's say our science class is in the motion unit. We're going to use this ramp for our investigations. What could be changed for this investigation? Please pause the video and create a list of ideas on a piece of scrap paper. Historically, we as teachers craft the investigations for students. We identify the investigation question, the materials, the procedures, and identify the data collection and analysis data. And finally, we determine how the results will be displayed and communicated. But what if we empower students to make these decisions instead? We could allow the students to choose in their materials, giving them options of materials that we have already selected for them that we know are safe. Allowing them to bring materials from home, specifically only for elementary. And again, the teacher needs to make sure the materials are safe. We as teachers can allow students to create their own procedures and explain the purpose of each step. And does the order matter? If you make a student think through these, then it gives the student ownership. On data collection, we can allow students to determine which data needs to be collected, identify which table format needs to be used. If indeed we can provide templates if a student is struggling, or allow them to problem solve through the creation of their own data tables. Finally, allowing them to take a data and create their own graphs and charts to show the relationship acquired in the investigation. For communication, we can allow students to have choices in communicating and showcasing the knowledge they have acquired in their investigation. They can write a lab report, create a video of their findings, create a science board or poster showing their investigation process and results, or finally, a presentation of the same information. Making these moves within our classroom gives students voice and choice. Besides student choices is to give them opportunities to enrich and accelerate their learning. For example, these are the Texas standards for force and motion. Let's say I had a 4th grade student who already aced understanding the idea of gravity and magnetism. However, they're ready for force and motion on cars and ramps. So we could stretch the students, sorry about that, to extend beyond the 4th grade standards and start working on 5th grade standards. This could easily be done in the classroom with different groups of students investigating different aspects of force and motion, allowing everyone to investigate different acts so students can meet their needs without appearing to be different from their peers or doing additional work. Thus, to recap what we have covered so far, we've talked about investigable questions, giving students some choice in how they conduct investigations, and finally, using the standards to extend investigation questions beyond their grade level to craft investigations and thus gain content that meets the needs of gifted and talented students. Finally, let's get to discourse. Before I go much further on discourse, I'd like to show you an example.
What claim did you hear?
I heard that if the glacier of mostly sand and some pebbles in the mountain, then the water would go slower.
Then the water would go slower. Do you agree or disagree?
Agreed.
Can you tell me more?
Because when we did the experiment with earth materials and we used sand, it went slower than soil, like pebbles. And I want to add on. Yeah, I want to add on to Jamie's. I agree with it is very compact and it has little tiny spaces in between for the water to go through. But I really think that sand went the slowest because sand has the most littlest things in it.
I love this video because I love watching the students talk and make their own connections. To make this work, there were definitely classroom procedures and protocols in place. One that we saw was the use of sentence stems. An example was, I think this. I would like to add to the conversation. I disagree with this because. Sentence stems work after the teacher has modeled it and doing a gradual release method on what it looks like and what it does not look like in the classroom. Furthermore, we heard some vocabulary in the video. This is a great area where gifted and talented students can be challenged and able to meet their needs. We can empower GT students to be challenged to go beyond the grade level vocabulary list to extend their vocabulary to a grade level or several grade levels above their current one. Another way the teacher can use discourse to meet the needs of his or her GT students is to make sure the students are giving evidence to support their idea. Finally, for classroom discourse to be successful, the teacher needs to create an environment that is supportive, encouraging, and not competitive. When you're using discourse with all types of students, including gifted and talented students, I would suggest that they use evidence to support their claim and their ideas. This evidence can be taken from a lab, like the chart that was shown in the video, personal experiences, and or sharing each other's experiences. Using evidence allows students to share with who they are, their ideas, and their knowledge gained from research or investigations. This encourages GT students to own their own learning, make connections, and give them areas where they can shine. Again, this does not happen overnight, and it requires intentional classroom practices and protocols to make it happen. So, what have we talked about today in such a short time? And what are the next steps? Today, we've talked about investigable questions. If you want to know more about investigable questions, I've listed the 4 websites on the left, plus some action items that you can select on how to implement this in your classroom. We've also talked about differentiating investigations in your classroom. So how do we go from everybody doing the exact same investigation to having multiple investigations going on at the same time? If you want to know more about this, there are 4 websites and resources for you to look at and some other action items for you to implement in your classroom. Finally, we also talked about discourse. If you want to investigate more about discourse, I've provided 5 websites to give you ideas on how to model discourse within your classroom. And this is added bonus. Finally, I've given you some additional resources for the gifted and talented students. This list includes things like creating menus for enrichment of PBLs and other extension activities for your students when they have already met the standards needed. So, thank you so much for attending this session. If you have any questions, feel free to reach out and contact me. My name is Jennifer Culver. Again, my email and my phone number is listed on the screen. I wish you well and hope that the rest of your summer is grand. Thank you very much for all that you do for our gifted and talented students.